Sulfur dioxide has one lone pair and four bonding pairs, two double bonds. It is covalent, which means it shares electrons and does not separate, plus it has two nonmetals. Sulfur dioxide is a bent V shape with a bond angle of 120 degrees. It is polar because sulfur has 6 electrons and each oxygen is 6,2, which means there are 18 electrons in total. The lone pair in sulfur disrupts the equal distribution of charges amongst the entire molecule, making one side negatively charged and the other side positively charged. The principal intermolecular force between sulfur dioxide molecules is dipole-dipole attractions, and there are London forces existing. Sulfur dioxide is hazardous, such as most of the other components of its category. It is a toxic gas, which brings an irritating smell. Unlike the others, this is not chemically formed, but is released naturally by volcanic reactivity.
Methane is made up of carbon and hydrogen. Thus, hydrogen has 1 electron and carbon has 4 electrons, which means it requires 8 of hydrogen. This is like one of these. Hydrogen shares its electron with carbon, well, each of them does, making 4 sigma bonds, 8 electrons for carbon and 2 for each hydrogen. Since hydrogen is sharing one of each of its valence electrons from carbon, there are no lone pairs in methane. Methane is formed by sharing of electrons between hydrogen atoms and carbon. Methane is formed by non-polar covalent bonding. It does not produce dipoles, so it's non-polar. In a methane molecule, 4 hydrogen atoms are linked to 1 carbon atom by single covalent bonds. The 4 valence bonds of carbons are arranged tetrahedrally in space. Thus, a methane molecule has been a tetrahedral shape. It has an angle of 109.5, which would be right there. And yeah, so unlike sulfur dioxide, which isn't a naturally produced, methane is a greenhouse gas, which is usually made not in natural conditions but in a lab. It is highly hazardous, like hydrogen cyanide.
The carbonate ion has no lone pairs and 1 double bond. It is ionic and the bond angle is 120. It is a trigonal planar, which means they arrange themselves as far apart as possible. If all 3 of the outer atoms are the same and there are no lone pairs of electrons around the central atom, then the molecule is nonpolar. Therefore, carbonate ion is nonpolar. There are 3 intermolecular connections and the ionic forces existing. A carbonate ion and an oxalate ion consist of the same properties. They both belong to the group called oxocarbon anions, which is a negative ion group consisting solely of carbon and oxygen ions. This gives them different properties than the other compounds in the group.
Hydroxide ions are made up of oxygen and hydrogen. These have 3 lone pairs, as you can see right there, there, and there. So, they are straight because there's only 1 intermolecular bond between them, right there. And diatomic ions, such as the hydroxide ions, are only able to bond with elements in the same or similar properties. But polyatomic ions, such as ammonium or phosphate, can bond with ions that are composed of 1 or more than 1 element. This shows the difference between an hydroxide ion and the other ones in this group. So, in conclusion, there are many interesting different properties and bonds between these compounds that we have shown above.